Very good morning. Welcome you all to the NPTEL course on Advanced Distribution System Analysis and Operation. Today we'll be talking about fundamentals of power distribution network, and within which we'll be also touching upon the differences between power transmission and distribution networks, impact of distributed energy sources, and finally the operational challenges associated with DR integrated distribution networks. Now, an electric grid is a network of synchronized power provider and consumers that are connected by transmission and distribution lines and operated by one or more control centers. As you could see that we can have actually generation, as you know, the generation centers, and through transmission and distribution we can make our consumers to be engaged with actually load consumption. However, considering the current impact of electric vehicles, they can also be used as a consumer, and at the end distributed energy resources such as PV and batteries can also be integrated into my distribution system. Now, as you all know, electrical power grid, which is one of the most complex power system that mankind in its history has realized, and as you could see the power map of India, I mean almost like it's a mesh net, almost every corner of the villages are being integrated with the master transmission and distribution systems. Now, when you talk about electrical power grid, I mean we do have actually billions of independent and connected devices and millions of independent and connected users, and the different needs and possibilities. That means what time, who is going to use what kind of devices is not known to anybody. However, there is a simultaneous production and consumption with no significant storage. That means the moment we switch on our air conditioning system at our residence, we expect the power to be available to me. Now, the physical specifics such as frequency, voltage dynamics is something different. We want to have 50 hertz, we want to have 230 volt at all the time. And finally, the financially intensive with long component lifetime and payback period, which is competing in the spot market, which is going to be another challenge in today's era. Now, when you talk about power system, which is the greatest engineering achievement, we can also say its design and operation are much more complex than any aircraft today. We seem to think we can randomly connect new devices to it with no overall game plan in mind. So, anytime we connect a device with our own choice and we see that is functional, and that is the beauty of today's electrical grid. And specific to India, I like to highlight the complexity this country do possess today with millions of consumers with random choices of devices. Still, God is very kind to Indian power grid. It is still operational and quite resilient in nature. Now, let us focus on architecture of electrical power grid. As you know, there are three major components of electrical power grid. One is going to be generation, the second one is going to be transmission, and the third one is going to be distribution. Now, generation, which is the initial stage where electricity is generated from different energy sources such as fossil fuels, coal, oil, natural gas, power plant. Then we can also have an opportunity to experience with nuclear reactions, that is nuclear power plants. And along with that, we do have renewable sources, which are solar and wind majorly, but considering its green hydroelectric power systems also can be considered as renewable sources. Now, once you generate, that energy need to reach to my consumers through transmission and distribution systems. Now, let us focus on transmission systems. Electric power transmission is the bulk movement of electric energy. It's basically transporting electrical energy from the generating point to a distribution system, from an electricity generating site to distribution network. Either it could be AC system or could be HVDC systems. We'll talk more in detail about the AC and HVDC in due course of time. But then once the energy is available to me, a distribution network, it is the delivery of electricity to consumers at lower voltages. So, we as a consumers are always connected. The room where I am recording my lecture now is a kind of a consumer point where we are connected to distribution system of IIT Roorkee. Now, you can also see the diagram which talks about generators, and then we step up transformers because the voltage need to be upgraded to make sure that the current flowing is quite low, and hence my losses will be low, and the transmission level, which is of different size, 132 kV, 220 kV and 400 kV, and then slowly we step down, coming back to sub transmission level and further step down to primary distribution. And then the distribution system distributes its energy requirement to the consumers through secondary distribution system. So, as you could see, this is 440 volt 3 phase, which is nothing but my 230 single phase available to me. Now, what is importance of distribution network? There are so many aspects that we can look into. First is the distribution network is expected to be extremely reliable. So, reliability is one of the important concepts. Then, which is the distribution network is expected to ensure a continuous supply of electricity, which is essential for homes, hospitals and industries. All the time we expect the energy is available to me. And the second one, which is economic growth and development. Now, any distribution network are critical for economic growth by providing the necessary infrastructure for businesses to operate and expand. Until and unless there is electricity, no business model can survive. And as you all know, economics and electricity, they go together. Your economy to grow, the energy available to the consumer must be enough. Third one, safety and scalability. So, well-maintained distribution networks reduce the risk of electric accidents and fire, ensuring the safety, and efficient distribution system can accommodate increasing demand as communities grow and industries expand. So, it has the capacity not only to provide safety to consumers, but also need to scale up as and when required. Last point, facilities renewable energy integration. The distribution network must be in a position enables the renewable energy to be integrated. Means your distribution system is such which may be in a position to accept the generation available to me through renewable energy at any given point of time. Now, it's a very interesting storyline. All of you please concentrate. Electrical power distribution development timeline, which is very, very important. It is as old as 1880, the distribution system feeding arc lamps. The history begins in the year 1880, and then slowly we move to 1890, where Edison's DC network in New York City, which has been experimented, Westinghouse AC distribution system and paper insulated underground cables are discovered in the year 1890. Then we slowly move to 1900, where emergence of AC technology as superior to DC being proved, and 1910 mainly 2 and 4 kV distribution networks are being experimented. 1920, auto reclosing circuit breakers are not only designed but also demonstrated in its application in the field. 1930, metal clad switchgear, completely self-protected transformers, and then 1940 hydraulic reclosures, 1950 growth of 15 kV distribution move to multi-grounded neutral systems, 1960 pedal-mounted transformers, 1970 we move to rapid load growth and rise of 25 and 35 kV distribution system. So, as you closely observe over a period of time, it is not only the technology, but the high voltage experience in distribution system and the components within distribution system started emerging or evolving. 1980, we could see the TR XLP cables, amorphous core distribution transformers and metal oxide riser pole arresters. 1990, the creation of increased load sensitivities, computers, digital clocks, and so on and so forth. 2000, emergence of distribution scale generation technology. 2010, increase in automation, AMI, and other smart grid technologies. 2020, we move to more integration of distributed generation, popularly known as microgrid, distribution system automation, and intelligent control. I am very sure and confident that you must have gone through my previous course on smart grid technologies, which is also covering from basic to advanced technologies. Probably this is the era where we need to focus on not only smart grid technology, and to accommodate those smart grid technologies with renewable integration, storage technology, the distribution system must be in a position to accept it. So this course is extremely important, which is advanced distribution system analysis and control, which accommodates active distribution system for practical applications and field deployments. Now, what exactly the traditional distribution system look like? The traditional distribution network, as you all know, let me explain through this diagram. All of you once again take your notes if possible and then try to practice. First of all, we have a grid which is high voltage and medium voltage substation. And then the supply, this is the main grid which is available to me. And then we supply to the residential networks with 3-phase. Okay, and this is 3-phase 4-wire low voltage network. Why 4-wire? Because we can also experience the neutral. So this is my 3-phase, and we do have a neutral. So anytime any single phase can be brought from your neutral to a single phase. And then we have urban network, and sometime for rural we only need a single phase, so we need not waste a lot of money for 3-phase infrastructure, so we focus on single phase network. And regarding the sources, so because these are all my consumers, and as you could see, the diesel generator which is feeding power to the grid, and then finally we have actually different voltage regulators and then capacitor banks, and also we have the grid. Now let me quickly understand any system which will have a grid supply, and probably it can have actually diesel generator, and over a period of time we'll see instead of diesel generator we can also have a bit of renewable energy penetration. That could be from actually PV or could be from wind, depending upon the availability. All right. So let's move further, try to understand more about traditional distribution network, in which the power flow which is unidirectional, and the higher energy losses lead to additional energy cost, low voltage problems as farthest end, diesel generators are connected to supply during peak hours, and then voltage regulators and capacitor banks used to improve voltage profile in the network. Now there are main important point in a distribution system. I do not know or any part of the rural villages. We all might have experienced little bit of voltage fluctuation during evening hours. So because in the evening hours, the load is so high, the voltage actually started dropping. Am I right? So we normally don't experience close to 230 volt. It may be sometimes 225 and as worst as 220. So my lighting system sometime flicker if it is going to be LED system, or it is going to be dimmed with a supply which is below the required voltage. And why it is happening? Because when you talk about a long rural distribution line, which may be single phase and sometimes even 3-phase, but over a period of time when the cable is continuously running for more than half a kilometer or maybe 400 meters, then the voltage drop is so significant due to the loss of, resistance of the cable. So the voltage experience for the end consumers are significantly lower down, and hence we consumers situated at the complete end will experience a voltage drop. So that is what the common problem we have seen. And then one more important part, just to give you a bit of background, the carbon dioxide CO2 emission from coal in India, which is significantly increasing, because as you all know that because India is a country which depends mostly on thermal as well as hydropower plants. So we are mostly dependent on coal-fired power plants, but considering the recent Paris Agreement where we decided not to go for any more emission to the earth, so we decided to reduce the carbon emission. So I'm very happy to announce the carbon emission of India in recent time got drastically reduced. And that is, it was keep on increasing, but after actually 2023, as you could see, it is drastically reducing. So that means this drop, probably it might have gone here, now it is here. So this gap will be covered through my RES now. Renewable energy sources will be able to compensate. We'll see over a period of time how PV and wind is currently playing a very important role in this country to make sure that we are not further enhancing the thermal power plants operation, and probably it will be slowly phased out over a period of 5 to 10 years from now. And these are all generation mix, world scenario 2022. As you could see, even today, across the world, the thermal power plant or fossil mix is going to be significantly high. Total installation capacity across the world is close to 8,500 gigawatt, and the share of renewable energy is close to 39, that is 40%, and share of global renewable electricity generation is projected to surpass that of fossil fuels generation by 2040. So we expect in next 15 years, the generation from the renewable is expected to surpass the fossil fuel or thermal power plants. But for that, lot of determination, policymakers of the world must come out with new technologies, efficient technology, as well as economic technology, cheaper technology to replace thermal power plant, which is quite important. Now, let us concentrate on Indian scenario. So, it is as on February 2025, the Indian scenario is very interesting. As you could see, the thermal percentage, which is close to non-fossil is close to 50%, and non-fossil is also going to be close to 50%. So, to my understanding, the current operation of Indian power system is at its peak and able to accommodate maximum renewable energy to its best capacity, and probably the government's current initiatives are so encouraging. I am very sure that very soon the contribution from renewable energy resources over a period of time will be at least close to the thermal generation in next 3-4 years, and probably next 5 to 10 years time, the renewable energy will certainly surpass the fossil fuel or thermal generation of this country. Now, the total installed capacity of India is close to 470 gigawatt, and distributed generation such as solar, small wind is being integrated into the distribution network significantly, but we need to plan it properly. To my understanding, currently the Indian power network is too hungry, so any amount of renewable energy that you penetrate will be absorbed easily, but there could be a bit of stability analysis due to less inertia available with my PV. So, lot of new technology that need to be brought into the power transmission and distribution system to accommodate maximum percentage of renewable energy in future. Now, what is the status of distributed energy resources integration in India? Let us focus here. So, first of all, let us concentrate on rooftop solar. So, rooftop solar integration into distribution network increasing in recent year, no doubt, but as on February 25, we had approximately 16.66 gigawatts, so close to 17 gigawatt of rooftop solar. And electric vehicle is a very, very important area for Indian market, because as on 24, India boasts over 5.6 million electric vehicles, beyond imagination. So, and that is going to play a critical role, because currently the energy available to this country, especially to India, is just above the required energy during peak hours. So, now the worrying part that when we integrate lot of electric vehicle to the system, and those electric vehicles may get connected for the charging of their batteries at random way at any given point of time. So, the issue here, how do we, perhaps actually engage the electric vehicle charging systems at a point where it is not become a hurdle to my peak energy deficit scenario, all right. So, that is another concern where electric vehicle engagement is fine, but above and all, considering the energy scarcity or the shortage of energy in this country, we need to be extremely careful before engaging electric vehicles into distribution systems, and to make sure they are not being charged during the peak hours through some mechanism, and that is another research area I think you people can explore. And we can also explore, like to small wind energy that we have not done many of it. But today it is close to 3.3 megawatt. But India having a extreme coastal, both east and west, we need to exercise installing huge offshore wind power plant that can address my fossil generation reduction through excess wind penetration to Indian power grid. And that is the area perhaps we also need to work. So my dear research scholars or BTech project students, any one of you working in this field, please make sure that you are working in the area, the challenges associated with electric vehicles and the solution through excess wind penetration could be the best scenario for Indian power grid. And the last one, which is battery energy storage system, we have not done much as of today, but India is planning to integrate close to 1.6 gigawatt hours. But once again, I like to reiterate, until unless the storage cost is getting reduced significantly, it is very difficult to go in a mega scale. So probably new technology for battery energy storage systems with cheaper cost could be a solution for Indian power grid along with PV and wind integration. Now, slowly, the distribution network that we have seen as of now, they are actually conventional distribution networks. And the moment because you generate and then you consume, that was the past distribution network system. But today, it is not the scenario. Today, we can, as a consumer, I can consume electricity and I can have rooftop solar and I can also give back energy to the grid. So, I am an active participant to the grid, not only consuming, but also generating and supplying to the main grid. So, considering those aspects, having generation resources available at distribution end make my distribution network quite active. So, now let us focus on active distribution network, and this is what we have seen already. Okay. So, this is the network which you have already seen, and the penetration of distributed energy resources are increasing recent year at distribution level, and this is due to environmental concern, cost competitiveness, energy security and technological advances. And this distribution network become active due to connection of electric vehicles, battery storages and PV integration, and probably there could be a wind integration also. All right. So, this is what the new era, this course mostly focusing on the challenges, the solution, the management related to active distribution networks. Now, I am very happy to announce that IIT Roorkee campus is quite active in its nature, and we had a wonderful laboratory developed in recent time in the Department of Electrical Engineering known as Admire Lab. I request all of you to visit Admire Labs and its facilities available today, and with help of Admire Lab of Department of Electrical Engineering, I think currently we are trying to make the IIT Roorkee campus is a smart academic campus, and which also expected to be a more active distribution network in future. So, IIT Roorkee distribution network do have 21 substations, and we experience a peak load of 8 megawatt, close to that, and a minimum of 3 megawatt. And we have actually PV installation at 35 different rooftops of magnitude 2.7 megawatt, and the battery energy storage systems are integrated to network, and currently they are located in two different points. One is electrical engineering department, and the second one is at actually old humanities building, especially to cater the energy requirement of Mehta Family School of Data Science. So, with this we come to an end probably. Thank you very much, because this is quite fundamental. All of you might have enjoyed. Please have a look, revise the slides before we appear for the next lecture. Thank you very much. Bye-bye.